In this video, we're going to go over the solutions to the Systems Engineering Midterm Part 1. These are problems in engineering economics, also called finance. You can read for yourself that this exam is organized around a comparison of electric versus internal combustion engine vehicles. And it gives a hypothetical cash flow description of what it costs to purchase and operate an electric vehicle. So the first page is asking for students to draw the cash flow diagram, label the diagram, and use the correct units. So we're going to extract some crucial information. First of all, the timeline on the cash flow diagram will be enumerated in years. And working from year 0 up to year 8. Boom, boom, boom. So this would be 2, 4, 6, 8. The delivery vans cost $100K and typically, or $100K, so typically we draw a down arrow for money that's leaving the checking account. So this is going to be from the perspective of the purchaser. Then they require $8,000 a year, notice the units, to operate. So what's that going to look like in year 1, 2, 3, 4, 5, 6, 7, 8? Every single year is going to be $8,000 a year to operate. And instead of drawing all the arrows, which you could do, I'm just drawing this one rectangular cash flow diagram. You're going to recognize that pattern as an annuity, whereas here at time equals 0 is typically represented in the alphabet of finances. P here, this annual stream of operating cost payments is represented as an annuity, but there's more. A 22K battery replacement at the end of year 4. 2, 4. So here we have another 22K. And then what happens? We get to sell what's left of the van at the end of 8 years for 12K. So that's going to be an up arrow, 12K. This is the whole cash flow diagram. And again, I've taken a little bit of a shortcut here. I'll fill it in because these are all the operating costs. You're going to notice that our vocabulary is present value, that's the expense, annuity, operating costs, a future expense in year 4 for the battery replacement, and another future expense at year 8 for the salvage value. This, I call it an expense, but because we're collecting it from the perspective of the van owner, it's on the positive side of the cash flow diagram. Let's see what to do with this information in the next problem. Because here, they're asking us for A, the annuity in dollars per year that is equivalent to all of these expected costs. So we're going to need a few formula. What are we going to need? We want to convert P to A and F to A. And the good thing is that there's an equation sheet included with the exam. So if we want to go 2P given A, we would use this formula. But what we want to go is 2A given P. So that's this formula. When we're given P, the 100, we're going to multiply it by the discount rate is I, so that's 0.06, 1 plus I, 1.06, raised to the, we're looking at 8 years, divided by 1.06 raised to the 8 minus 1. So what have we done here? We've converted the P term to an A, but we still have the F4 and the F8. So what's F4 going to be like? Well, 2a given f. We want this equation. What's that going to look like? 22, this is the replacement cost of the battery, times 0.06, I'm getting that from here, divided by 1.06. 4 years is when you got to replace the battery, minus 1. Plus, and I should be very careful here about my units, because I've adopted this convention that everything down is going to be positive in this equation. And that's a dangerous convention because we could have thought of it as negative because these are all costs. But here at F8 is when I must be consistent. I could say plus 12, but remember, we're collecting that salvage value. So according to this confusing sign convention, it's got to be minus 12. 0.06 over 1.06, this time at year 8, minus 1. And then what about the operating costs? Well, they're already in units of dollars per year, so we don't have to convert them at all. We will just add them to the end. Now we have some calculating to do already in A. So what do I got for a calculator? I said that it's useful to use a programmable calculator. Unfortunately, I'm not using one of those. I have one of these crappy, it's sophisticated, it can use trigonometric functions, but it's a pretty crappy calculator. Let's see what we get when we put all of this into my crappy calculator. Divided by the quantity 1.06 raised to the 4 minus 1, negative 12 times 0.06 divided by the quantity 1.06 raised to the 8 minus 1 and parentheses plus 8. Boom, 27,920. So in this case, A equals 27,920 per year. That is the equivalent amount in annual expenses. If you amortize the 100K initial investment, you amortize the battery replacement, you amortize the salvage value over the entire 8-year period, it's equivalent to about $28,000 a year in expenses. Let's move on to the next problem, which explores an alternative. Suppose that we wanted to use an internal combustion van instead of the electric vehicle. We have different statistics or different information about the cash flow diagram. And it isn't easy to organize because the internal combustion van has to be replaced every 6 years rather than every 8. It's true that the engines on the internal combustion vehicles, they wear more quickly. And so whatever the reason is, these are the new numbers. And it's asking us to draw a cash flow diagram that represents the difference. It's a lot of information to keep track of in your head. So I'm going to do something specific. Let's start with the electric van. And what I want to do, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is represent the cash flows in a table for every single year of the next 24 years. 11, 12, 13, 14, 15, 16. And this is just to help me keep track of all the complicated information. Here's year 0. So the electric vehicle starts off with an expense of 100, and we can see that right here. Then, at the end of year 1, all the way through to year 24, it's going to be minus 8. Terrific. Then there's some special years. Got to replace the battery in year 4. I get some salvage value in year 12. I got to replace the battery again in year 16. And That's not quite right. I said year 12, negative 12. I got to replace the battery again in year 12. This is my salvage value in year 10, plus 12 I collect. Year 12, negative 22, another battery replacement. By the time I get to year 16, I get the salvage value again, but then by year 20, another battery replacement, and then in year 24, I get the salvage value. So we've represented everything in the cash flow diagram here in a tabular format over the 24 years. Let's do the van. The van only costs $50,000 to purchase, so that's year 0, and we know it's got to be replaced every 6 years. So I kind of overlooked that in the electric vehicle. Negative 100, another replacement. Negative 100 after 16 years. In the van, to do the same thing, I got to go negative 50 in 6 years, negative 50 in 12 years, negative 50 in 18 years. What are the operating costs? $33,000 a year. I got to operate it for the entire length, negative 33. And what about the salvage value? Well, I assume the same salvage value, but this time I collect it every 6 years. So what's that going to look like? Plus 12, plus 12, plus 12 for 18, and at the end, another plus 12. There's a reason that I've tabulated these, and that reason is I want to get the difference. So in every year, I've got one cost minus another cost. What's the delta? In year 0, negative 100 minus negative 50 leaves me with negative 50. And then you can see how it's going to be negative 8 minus negative 33. That's plus 25. In year 4, negative 22 minus nothing special. Oops, I'm going to put that up here because this 25 goes the entire length. In year 6, it's 0 minus a negative 50 minus 12, that's plus 38. In year 8, negative 100 plus, that's negative 88, nothing happening in the van, so it's going to be negative 88. And I continue down every single year. Here's negative 22 minus a negative 50, that gets me to plus 28, minus 12, plus 16. Negative 88, 0 minus negative 50, that's positive 50, minus 12, positive 38. It's really difficult to do it all in your head, and so I'm writing everything down. And then this final year, which is a little bit different, I get the negative 8 operating costs, plus 12, I'm at plus 4, minus the 33 operating costs, that's negative 29, minus negative 33 is plus 37, and then minus 12, negative. Let me do that again. Here, adding these up, positive 4, minus a negative 33, positive 37, minus 12, I get positive 25. To draw the cash flow diagram, negative 50, 24 years. Then I have the positive 25 for every year. That's the difference in the operating costs. And then I have some special cases. At year 4, looks like negative 22. At year 6, looks like positive 38. At year 8, negative 88. It's going to be important to keep track of all this on the next sheet, but for right now, we're just doing the cash flow diagram. Plus 16. Year 16, negative 88. Year 20, positive 38. Year, sorry, that was 18. Year 20, negative 22. And then finally, year 24 plus 25 because of the salvage value. This is the cash flow diagram for the difference, the delta cash flow diagram. It shows that the electric vehicle is $50K more expensive, but look at all these savings in operating costs. That makes the vehicle very attractive. It's going to be important on the next sheet. When we go here, and it says compute the incremental rate of return. My goodness, what a bunch of calculations. Let's organize these calculations in a way that makes it easier to see what's going on. Negative 50. This is about the difference. Compute the incremental, the marginal rate of return on the increased upfront capital cost. So I'm going to spend an extra 50 right away. And then what happens? I got to look at my cash flow diagram. Well, over here, I get to save 25, and this is in an annuity. So I'm going to multiply that by 1 plus I to the 24 minus 1 over I multiplied by 1 plus I to the 24. What I've done here is express the present value in the cash flow diagram at year 0, the increased investment of the electric vehicle. And what I've done here is represent the 24 years of operating costs. These savings are positive, and I've converted them with this formula to present value. We have some more conversions to do. I'm going to put all the negatives on this side. I'm going to put all the positives on this side. So what else is coming up? Well, I've got this negative 22, future value in year 4. And to convert that, I've got to go 1 plus I to the 4. What else? 88, negative 88 over 1 plus I. Let's be careful about where that falls to the 8. Terrific. I got another negative 88 over 1 plus I. And when does that show up? 16. I got another negative 22. And when does that show up? Looks to me like year 20. Terrific. In this side, I've tabulated all the present value of all the costs. And here, I'm going to finish doing the present value of all the benefits. I have some up arrows to keep track of. Plus 38, and that's at year 6. What else do I have? Plus 16, and that's at year 12. Plus 38 again, and when is that? $18. And then finally, plus 25. That difference in the salvage value at 24. 8 plus 12. That's not right. That's not the difference in the salvage value. I'm going to correct that right now because this negative 8 is operating. Plus 12 plus 12. When I subtract 12 and 12, I don't get a plus 25. I get 0. I did this cash flow diagram incorrectly because I put the operating costs in when I shouldn't have. Instead, I meant for this to just be the salvage values. They're identical, and so when I subtract them, they're both 0. Terrific. That makes my problem a little simpler. I have all of these terms to compute the incremental rate of return. It's the I at which these terms are going to equal these terms. The costs equal the benefits. So if you have a programmable calculator and you can put this equation in and hit the solve button on your calculator, it will kick out the correct I. But what if you don't? You got to guess. The easiest thing to guess is going to be I equal 0%. We can do that on our calculator here because we go 50 minus 22 minus 88 minus 88 minus 22. With I equal to 0, there are no discount factors here. We're just adding everything up. Then it's 20, oops, that was minus 22. Now I'm doing the plus side. Plus 25 times the 24 years, the difference in the operating costs, plus 38, plus 16, plus 38. What did I get? Positive 522. If this were 0, then the costs at I equals 0%, the costs would be equal to the benefits. But we can see here that the benefits are outweighing the costs when I equals 0. So we're going to have to guess something much larger. Let's guess I equal to, and I'm pulling this out of my imagination, let's guess 30% is going to be a very long calculation. Negative 50 minus 22 divided by 1.3 raised to the 4. That's here. Minus 88 divided by 1.3 raised to the 8. Minus 88 divided by 1.3 raised to the 16. Minus 22 divided by 1.3 raised to the 20. Now we do the positive side. Plus 25 times, here's a quantity, so I'm going to open the parentheses, 1.3 y to the x, 24 minus 1 divided by 0.3 divided by 1.3 y to the x, 24 plus 38 divided by 1.3 y to the x, 6 plus 16 divided by 1.3 y to the x, 12 plus 38 divided by 1.3 y to the x, 16. Boom. Now we get 22.4. I'm going to show you something. As we increase I in percent per year, and we look at the difference between the present value of the benefits and the present value of the costs, up here with I equals 0, 522. And here with I equal to 30, 22.4. Now 22.4 ain't exactly 0, but it's pretty close. This relationship typically goes like this. So the break-even I might be somewhere around 33%, approximately. And it is okay for us in an exam situation to have an approximate answer. We may even have made a mistake in how I set up this table and this equation. You saw that I made one here when I incorrectly added the operating cost. Those mistakes are not what we're going for. What we're looking for here is conceptual understanding of how to set up the model that will complete the calculation. Whether you came up with 33 or something close to it is not as important as whether you've organized the information correctly and set up the equations properly so that you can find a solution. Let's go to the last page. The last page is asking about inflation. Draw a graph depicting the expected real incremental rate of return. So this is what we were calculating on the previous sheet as a function of inflation rate. that graph is going to look like this. Percent per year, and the expected rate of return, also known as delta internal rate of return in percent per year. If the inflation rate is 0, then you know we're starting somewhere close to 33%. Terrific. The equation of the real rate of return, real equals effective, that would be inflation 0 over inflation minus 1. So it's 1 plus the effective rate all over 1 plus the, and we know this from class, 1 plus the inflation rate minus 1. What would happen when the inflation rate goes to infinity? It doesn't really matter what the effective rate is. At inflation rate equal to infinity, we get minus 1, because this term is 0. So it's important to keep this asymptote in mind. Whatever the effective rate is with inflation rate 0, it's this intercept. And we know that the shape of this curve is going to look something like this, concave up. That's the graph. Concave up with this positive intercept asymptotically approaching -1 as inflation goes to 0. Make a recommendation to the delivery company. I say, in this example, with these hypothetical made-up numbers, you buy electric. Because when we guessed that the interest rate, the internal rate of return was 0, these benefits way outweighed these costs. Now that doesn't tell us what the internal rate of return is. It's not likely to be 0. But when we estimated at 30%, that's a pretty good rate of return. If we had estimated 1% or 2%, we might still be on the fence about the recommendation. But because this incremental rate of return is so good, 30% is hard to find in the markets, our recommendation is buy electric. Those are the answers in all of their ugly complications to the problem that we posed for the Systems Engineering Midterm Part 1.